complex structure for question 1A is a tetrahedral because titanium is early transition metal and also it has 4 ligands attached with the central metal. The oxidation state of titanium is positive 3 because there is negative 1 charge of Cl ligand and 2 cyclopentadiene with negative 1 charge for each, and plus 0 is for CO because CO is a neutral ligand. For question 1B, the complex structure is trigonal bipyramidal because it has 5 ligands attached with the central iridium. The oxidation state of IR is positive 1 because there's only negative 1 charge of ligand C111C attached with the pH, while PME3 has 0, so 4 times 0 for 4 PME3 is 0. That's why IR plus negative 1 plus 0 equal to 0, and we get IR is equal to positive 1. For question 1C, the structure is a square planar because there is 4 ligands attached with the central palladium and also it has the 8 orbital. The oxidation state of palladium is positive 2 due to the negative 1 charge of ligand C111C attached with the phenyl and also negative 1 charge of ligand C111C attached with the methyl. The charge of ligand of ethylene diamine is 0 because it is a neutral ligand.
Okay, so for question 2, we need to do the synthesis pathway to synthesize the complex of trans dichloroethylene diamine thiourea platinum by given the trans effect order is thiourea is bigger than chloride and chloride is bigger than ethylene diamine. So first we need to do the synthesis from cis dichloroethylene diamine platinum. The structure, the drawing that we provide in this video is the synthesis for the complex. So since ethylene diamine is a chelating ligand, it will combine with the metal ion using the 2 nitrogen present. So chloride has a higher trans effect than ethylene diamine, which exactly has a higher liability. So therefore, the addition of ethylene diamine at the second step has led to cis isomer. On the other hand, the addition of chloride at the second step can lead to the trans isomer because the ethylene diamine trans to chloride is more labile than ethylene diamine to ethylene diamine. So it's given that thiourea trans effect is bigger than chloride and chloride is bigger than ethylene diamine. So when thiourea approach the square planar complex, it will form a trigonal pyramidal geometry and form the trans dichloroethylene diamine thiourea platinum.
Explain question 3, which said that choose the most stable complex from each pair of the complex and give the reasons for each choice. For first complex, the metal center is titanium, which has the oxidation states of positive 4. There are 2 Cp negative inside the complex and 1 Cl negative and 1 Cn negative with 1 metal center, which is titanium 4+. The number of electron in Cp negative is 6 electron. The number of electron in Cl negative and Cn negative is 2 electron respectively. And there are no electron inside the titanium 4+. So the total number of electron inside the first complex is 16 electron. For second complex in question A, the metal center is remains same, which is titanium, and the oxidation state of the metal center is also same, which is positive 4. From the second complex, there are 2 Cp negative and 1 Cl negative, 2 Cl negative, 1 NH3 and 1 titanium 4+. From the second complex, the total number of electron is 18 electron. So it means the second complex is more stable than the first complex because the second complex obey the 18 electron rules. For question B, the metal center for each of the complex is iridium. The oxidation state for each of the complex of metal center is positive 1. For question B, the second complex is more stable than the first complex due to the presence of C triple bond CPH ligand, pi back bonding, and sigma bond, which more stable.
For question 4, we calculate the effective atomic number, and the formula to find the EAN is Z minus X plus 2Cn. Z is stand for atomic number of the central metal, and X is for the oxidation state of the central metal, plus 2Cn. Cn is coordination number. It's times 2 because one of each ligand is donate 2 electron. And for question 1a, first we find the oxidation state of Au or gold. So 1 plus 2 times -1 because there is 2 negative with -1 charge of ligand plus Au equal to 0, and Au we got +1. Then we calculate the EAN. We have 79, which is the atomic number for gold, minus with -1 because we got the oxidation state is +1, plus 2 times 2 is 2 times 2 because there is 2 ligand attached with the gold. So we got 82 electron. For question 4b, we find the oxidation state for IR first. So IR plus 2 times -1 because there is 2 ligand with -1 charge, and then plus 0 because it is a neutral ligand equal to 0. Then we get IR is equal to +2. EAN is equal to 77. 77 is for the atomic number for IR minus 2, the oxidation state that we calculate for, and then plus 2 times 6 because there is 6 ligand attached with the iridium. Then we got 87 electron.